Today we are going to discuss about the binomial probability. We are going to derive the formula for binomial probability. Again, as you know, binomial means a discrete probability distribution, binomial probability. Discrete means we will get whole number values. So we are going to think of tossing a coin 3 times. So my number of trials, so we are tossing a coin 3 times, and in this case my number of trials n is equal to 3. Okay, this is this is an unfair coin. What does unfair coin means? Probability of success here is to head. So probability of success, which is to get heads, and which is given by small p, is equal to 0.6 in this case. Normally it is 0.5 for a fair coin, but this is an unfair coin. So probability of failure that is tails is 1 minus p, is 1 minus 0.6 is 0.4. Okay, so we are going to toss this same coin 3 times. Each time the coin is tossed, there are 2 possible outcomes. What is this? One success, that is head face up, and or one failure, that is tail face up. Okay, since I am tossing the coin 3 times, each of the time I toss a coin, there are 2 possible outcomes. So total number of outcomes in 3 tosses of this coin will be 2 for the first one, multiplied by 2 is equal to 8. This comes from the fundamental rules of counting. Okay, so if one coin toss has 2 possible outcomes, the next toss has 2 outcomes, the third one also 2. Total number of outcomes, or total number of ways in which this can happen, is 8. So what are the 8 possibilities? Okay, for example, we can have head. Okay, next one can be head, tail. Next one can be head, tail. Next one can be head, tail, head. Okay, or it can be tail, head. Okay, or it can be tail, head, and then again another head. Okay, or it can be tail, head, and tail. So we have 1, 2, 3, 4, 5, 6, 7, and the last one is all tails. Okay, so this is the way in which these 8 possibilities or 8 outcomes are possible. 4, 5, 6, 7, and 8. Suppose we are looking for probability of 2 successes. Okay, or probability of 2 heads. Now these are mutually exclusive. That is, one happens, that the other one cannot happen. So what are the ways in which we can get 2 heads? So this can be 2 heads possible when we get HHT is one possibility, okay, or we can get head tail head, head head tail, or head tail head, or we can get tail head head. Now as I said, these are mutually exclusive. We do not know which one exactly will happen. So when we are looking for a probability of 2 heads, it can be probability of head head tail, or probability of head tail head, or probability of tail head head. Since these are mutually exclusive events, these are mutually exclusive events, probability of 2 heads will be equal to probability of head head tail plus probability of head tail head plus probability of tail head head. Okay. Now let's look at the probability of head head tail. Okay. So here what do we have? We have the first one as head. Okay. So that probability is P. The second one is head also. Now again, these are independent events. So when the first toss is head, it does not influence what the second or third toss will be. So since they are independent, so like we are trying to find out probability of head and tail. Being independent, the probabilities will be multiplied. So probability of success of a head is P times P multiplied by 1 minus P. So probability of head tail, that means head and tail, is equal to P times P is P square times 1 minus P, exponent is 1, which we can think of as P square multiplied by 1 minus P. 3 out of 3 tosses, 2 are heads. 3 minus 2, exponent is 1. Therefore probability of 2 heads is equal to probability of head tail. Because these are mutually exclusive, we add the probability of head tail head plus probability of tail head. So let me write this clearly. So probability of 2 heads is equal to probability of head tail plus probability of head tail head plus probability of tail head. And each of them is equal to P square times 1 minus P, which is exponent 3 minus 2. Again, P square times 1 minus P, exponent 3 minus 2, plus P square 1 minus P, 3 minus 2. Notice the same term is added 3 times. So probability of 2 heads or 2 successes out of 3 tiles is equal to 3 times probability of success, 2 success, exponent 2 multiplied by 1 minus probability, exponent is 3 minus 2, which is 1. So in general, if we want to write probability of x successes out of n trials, that is our final goal in a binomial experiment, like tossing a coin. Okay, now before we do that, let's clarify what is 3. Okay, so remember P2 successes is 3p square 1 minus p exponent 3, total number of trials minus number of successes is 2. So what is 3? This 3 is actually 3 factorial divided by 2 factorial multiplied by 3 minus 2. So 3 is equal to 3 factorial. 3 factorial divided by 2 factorial divided by 3 minus 2 factorial. And that is equal to 3 factorial is 3 multiplied by 2 multiplied by 1 divided by 2 factorial is 2 times 1 times 1 factorial, which is 1. And that is equal to 3 because 2 times 1 is common in the numerator and denominator. So, so this term 3 is equal to 2 successes. It's actually, we can write this as, let me write it, this is, in general, this first term is NCX, X successes. Here we have, I meant 2 successes out of 3 trials, NCX would be X successes out of n trials, or it's a combination or number of ways in which combination of X successes out of n trials without regards to order. Without regards to order. So when we want to write out probability of X successes out of n trials in a binomial experiment, binomial probability experiment, the final formula which we tend to use is this, is equal to NCX, which is a combination of X things out of n, or number of ways in which we can select X items out of n items, or X successes out of n trials, multiplied by probability of success raised to the power of number of successes times 1 minus p, which is probability of failure raised to the power of n minus x. N is your total number of trials, x is your success, so n minus x is your failure. Okay, so probability of X success out of n trials in a binomial probability experiment is given by this formula, NCX, which is combination of X things out of n items without regards to order, multiplied by probability of success exponented or raised to the power of X, which is number of success, multiplied by 1 minus p, which is the probability of failure raised to the power of number of failures, n minus x. Okay, so that is the way the binomial formula is derived, and here I showed you how it is done. I'll stop here today. If you have any question or comment, please do not hesitate to write me a note. If you like this video, please give me a thumbs up. I really appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And also please do not forget to click on the bell button, which will let you know every time I upload a new video. Thanks for watching, and please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for taking the time to watch this. Take care. Have a nice day. See you next